look at 7 part 1 then. How many such, oh, sorry. Already skipped the reading the question part. Okay, so a 4-digit number begins with 1 and has exactly one pair of identical digits. Not necessarily adjacent, okay? So now 1, how many such numbers can be formed if the repeated digit is 1? Let's draw out what we have, right? 4 slots, we need 4 digits, and we know that it begins with 1, right? And has exactly one pair of identical digits. One pair of identical digits, we're assuming that it's, so say 1, 1, okay? That's it. There's no like triple ones, right? Because it won't be a pair. Now, say the next slot, I'll have my 1, okay? So first one is obviously one choice, right? Second one, I'll have one choice. Say I have my one choice and I'm going to repeat my number 1, okay? I'm satisfying my condition first. Satisfy condition first, repeated digit is 1. Now, after I pull 1, right, I'll go from, I'm assuming, okay, this question will go from 0 and all the way to 9, okay, right? Because 0 to 9 each is a different digit. So I know that 1 is my exact pair of identical digits. Then the rest, I cannot use 1. So over here, I'll have 9 digits left from 0 to 9, but 0 to 9 is 10 digits, so excluding 1, okay? I'll have 9 choices for my third slot, and I'll have 8 choices for my fourth slot. Why? Because these two numbers, your number 3 and number 4, cannot repeat, okay? Now, we're not done yet, okay? Over here, we'll have we have 3 slots, and as he said, not necessarily adjacent, okay? 1 does not have to be next to 1. So what we essentially can have is 1, 9, and then our 1 over here, and which is mixed up by our 8 digits. That's possible. What I mean is these 3 slots, right? Our fixed one, right? Fixed number 1 and our choices of 9 digits and our choices of 8 digits, they can swap around. So what happens is I'll have my 1 times 9 times 8, right? Because first one is fixed, there's no other choice. If you want, you can do 1 times 1 times 9 times 8, right? Using the slot method. And then for the last 3 digits, I'll have a combination of 3 factorial. Okay, because the 3 of them can be in different positions, as in like 918, I can have 981, right? I'll be having 6 combinations. So what I will get is 9 times 8 times 3 factorial. And then 8 times 3 factorial, what I get is 432 combinations. Okay. Part 2, let's have a look on what it says. So part 2 says, stop working. How many such numbers can be formed in total, right? So we now know that we either have one repeat, we don't have one repeated now, right? It doesn't have to be 1, but however, I still have my 4 slots, right? First is fixed with 1. And then how many such numbers can be formed in general? Okay. Let's consider this question such that we have our 9, right? We have 9 numbers. Why? So let's consider 1 is not the repeating digit, okay? 1 is not the repeating digit. Right, so now we know that 1 isn't the repeating digit, okay? So we'll have 9 choices. And then for our second slot, right? We're not repeating 1. So again, we'll technically have 1 choice, right? We'll be repeating the second digit. And then we'll have 8 choices left. Okay? So now instead of repeating my 1, I still have 1. This is still a fixed number. But instead of repeating 1, it will be repeating whatever I choose for my second number is. Okay? This means I'll have 9 times 8, right? Oh, well, 1 times 9 times 8, and then times 1 again. However, it can repeat my 9th digit, right? Where you can repeat the digits, which I have 9 options left, which is 0, 2, 3, all the way till 9. Or it can repeat these 8 digits, right? Which means I need to times it by 2. Okay, it can repeat either one. It can repeat the second digit or it can repeat the 4th digit. Again, they'll have 3 available positions. All 3 can move around, right? The fixed digit can be at the front, or the fixed digit can be in the middle. The fixed digit can be at the end, or be timesing by 3 factorial. However, we do have, say the repeating number is 2, right? So I pick 2 over here as my 9th, and then I'm repeating with my 2, and then I have my 8. You'll realize that although I have 3 combinations, but I have 2 repeating numbers, okay? Having that 2 repeating numbers makes me divide by 2 factorial as generally, right? How we have like say good, right? How many arrangements we can have for good is 4 factorial over 2 factorial, right? Because 2 of the O's are repeating. Okay. Then this becomes our formula for the ones that's not repeating. For the digit that is repeating but not 1. So what I have over here is 9 times 8 times 2 times 3 factorial or 4 factorial is just times by 3, okay? So I have 9 times 8 times 6, which is 17. 48 times 9, right? So I get 432. Okay, but let's look back at it. We said originally, we know that 1 isn't the repeated digit, okay? So hence now we need to plus when 1 is repeating. So therefore, total ways is equal to 1 is the repeating digit, plus 1 is not repeating digit. Okay, so 432 ways. This is from our part 1, right? And then plus 432. Yep, 432 plus 432 ways. So what I get is 864 ways.